up and back about 60 metric tons.
James?
James Dean, Florida Today. Ms. Shotwell, so much talk last time about the history-making event of being the first private vehicle to visit the station, but can you contrast that with the moment we're at now, where this is the first, flight that counts, if you will, the first real operational contracted flight?
I'm not sure any of the engineering team, frankly, or myself, feels like this is substantially different than the last one, with the exception that we got there once. We demonstrated we could do it. So there might be a teeny bit of relaxation. Not a lot, though. We're a launch company. I'm excited every time we get to launch. So this is obviously a very exciting time to be back. We were very much looking forward to moving from that development phase of the Falcon 9 and the Dragon into the official operational phase. So that part is actually quite exciting.
Bill.
Bill Horowitz, CBS News, with one for Gwen and one for Mike Suffredini. But for Gwen, you mentioned the 20 metric tons is required by the contract. And this is a contract question. It's not a bad karma question or anything like that. But if one of the missions in that 12 fails to get there for whatever reason, is there a contractual, what happens? Do you have to refly it at your cost, or does the government eat that? Or I just don't understand how the contract works.
If there is a mission failure, we actually don't get fully paid for that particular mission. I don't necessarily want to go into the details on that, and it depends on what kind of failure occurs. Given the amount of the capacity that we have on the Falcon 9 and the Dragon flights, I don't believe there is any chance that we won't hit our 20 metric ton target.
And for Mike, can you give us a little update on ISS systems? I remember when you guys replaced the box here a couple of weeks back, there was another box that had gone down that you guys were deferring to a later date. Where does that stand? And I've seen some mention of some coolant issues on P6, and I was wondering where does that stand, and what are you going to do to resolve those? Thanks.
Sure. The system you're referring to before was the Power Channel 3A, and shortly after the SpaceX vehicle arrives, we're going to go ahead and do the troubleshooting. So we don't know what the cause of what was apparently a very large short in the system that it reacted to. It's a number of components, a distribution component we call a DCSU, the beta gimbal that the power goes through could have had a problem, although it's very unlikely, or what's called a sequential shunt unit. This is where all of the 82 channels of power that come through a solar array, they go through a sequential shunt unit, and then it's fed to the station as it needs it. And so that's a potential source of this short circuit. So what we're going to do is after the SpaceX vehicle arrives, we're going to configure ourselves to a lower power by taking some of the batteries out of the system, so if the short's still there, we don't damage anything, and then we'll slowly start bringing these systems back online to see if we can isolate the short even if it's still there. So that's forward work for us. As soon as we figure out what the ORU is, then we'll know what to go do to repair it. And in any of those cases, that's an EVA to go do that. Now P6 has had a ammonia leak since it came to ISS. It's been very, very slow. And in fact, not too long ago, one of the last shuttle flights, we filled the system back up with a capability that's designed into the station to feed ammonia from the ammonia tanks out to any of the IEAs that may need ammonia. But in the mid-June time frame, the leak rate started to change. And you have to remember, you get thermal swings with these systems, and it's obviously a very slow leak, but over the last 2 or 3 months, the leak trend has started to increase. And so now it's at the point that we will potentially trip the limit on the cooling system, where it will shut off somewhere around the 1st of January 2013, so not far away. So now that's also one of the things we have to go look at. So we'll have to sort through those potential sources of the leak, or either the radiator itself, the coolant pump, or the lines within the system. We're actually very fortunate that this is on the P6 side, which has the early ammonia system, and there are options to go use some of those components to recover that system. But all of those, it's just a matter of trying to isolate the problem and fix it. And so part of what we're talking about now is when we might do an EVA and what we would go after. So we'll have to do some work on the 3A power system, and then decide what we would want to go do.
these two issues, depending on how it plays out, that's 2 EVAs, I'm guessing, and is that before the end of the year for both of them?
Well, we haven't made any decisions yet, so we're talking amongst ourselves as we like to do, and we tend to spend a lot of time on it. But we won't have a crew to do an EVA until the crew arrives in late December. And so we need to consider whether we need to do an EVA sooner rather than later, and if we decide we need to do it sooner, then we'll have to do it with Sunny and Aki. And with their departure date currently scheduled for the 12th of November, we're going to have to get on with it. So we are talking about that. If we think we can get along, or if the data tells us we can go much beyond January, then that would give us an option to just wait. We'll talk about that thoroughly here in the near future, and I think you'll see us kind of lean towards trying to get an EVA done before the Sunny and Aki leave.
Okay, we'll take 2 more questions here, one here and one on the other side of the room before we go to the phone bridge, and then we'll come back for more questions. Go ahead.
Hi, I'm David Bankston with Dave Travel's web series, the social media team, and this is for Gwen. What did you learn? What was the most important thing you learned from the last mission?
This isn't really a learning, but it was a critical element that spaceflight continues to be very, very difficult. And even though we did make it successfully, there was a lot of hard work that went into that particular mission, especially if you were watching the proximity operations and actually getting to the capture box. So this is not easy. It continues to not be easy. Hopefully we get better and better at it as we go. But it's a good reminder that this is really hard.
Okay.
Art Harmon, SaveManSpace.com. Will you be this Dragon will be on the space station for what, 50 days or something, and then returning?
It's about 3 weeks.
3 weeks. Okay. Will you be parking one at the space station for like 6 months to validate its use for manned missions?
We would have to talk to Mike's team. Currently, there is no plan to have Dragon on station for 6 months. There are other ways to demonstrate life for Dragon. We could fly it independent of the International Space Station to demonstrate its life.
Thank you.
Mm-hmm.
Okay, we're going to go to the phone bridge and take a question from Tareq Malik and then come back here. Tareq, are you there?
Yes, thank you. It's Tareq Malik from Space.com. And I had, I think, one question and a follow-up. My first question is for Mike. I know that this is a fairly full cargo trip to the station. I'm just wondering if there's anything special that you might have stored aboard for the crew when they open, something as a surprise. And I have one follow-up. Thanks.
Special for the crew. Well, we are flying things up for the entire team, and we talked about flying ice cream. Although I don't know if we ever got that on board. Did we ever get ice cream on board?
I don't know. We should get ice cream on board.
So I don't know the answer to that. When I just got back from a conference, and I haven't been able to check up to see, but we did talk about flying ice cream up because we had the freezers installed. But I don't know. We ended up doing that. But every flight we bring up a number of components. We bring up research, and we try to generally bring up what we call bonus food for the crew. And this is one of those flights that will have that. And so that in and of itself usually are things that the crew prefers to have. So that will fly up, and I'll have to check on whether we got the ice cream on or not.
Thank you. And just as a follow-up for Gwen, I'm curious about the Falcon 9 for this mission. If there is an opportunity that you've taken for a secondary payload, either with a private partner or someone else, just to take advantage of any additional upmash you might have for this flight. Thanks.
We are flying a secondary on this mission. We're flying a prototype satellite for the Orbcomm OG2 upgrade to their constellation. It's a 165-kilo satellite. This prototype needs to operate on orbit before we go ahead and launch 8 to 12 of them on a dedicated Falcon 9 mission. That's the only secondary, though.
All right. We're back here at Kennedy.
Hi. This is Emily Carney with this Space Available blog with social media. My question is for Ms. Shotwell. Why for SpaceX is there an instantaneous launch window?
It's not exactly an instantaneous launch window, but it's pretty darn close. If we were to have to recycle, basically you have to launch into an orbit plane where you're going to have a conjunction with the ISS. You want to rendezvous with the ISS, and those windows tend to not be long. However, if we were to recycle, we could not recycle in time to get another mission off in that period of time. So that's why it ends up being an instantaneous launch window.
Yeah, and I'll add to that. Every time you try to rendezvous with station, there's a precise point where you launch. It's the most efficient because you're launching right into the plane with the vehicle. So in the shuttle, we had additional performance, and so we got a whole 10 minutes worth of a window. But many of the vehicles, including the Soyuzes that launch the Progress and the crewed vehicles, have very, very small windows in order to conserve the performance and be able to send more to the station. So that's true in all vehicles, including this one.
On our static fire, we did hit T0 on the money, so looks good.
I'm Jim Howard, social media from Texas. I have just two quick questions. Are there any possible weather constraints associated with rolling your vehicle out and erecting it that could delay the launch? And the second one is, as a Texan, I have to ask, can you comment on the possible SpaceX facility in Deep South Texas, possibly around Brownsville?
Okay, so we could have the vehicle out on the pad during the rain, but we don't have to do that. So we're going to roll out. We're attempting to roll out, or we were going to at 6 p.m. this evening, depending on weather. We can roll out any time we have to be vertical by about 1 p.m. tomorrow. We've got late load cargo, hopefully the ice cream that Mike was referring to, that will load. That operation starts at 6 a.m. tomorrow. So we want to be horizontal and out of the hangar by 6 a.m. tomorrow, but we do have some flexibility. And as far as the launch site goes, we continue to look at a number of launch sites. We happen to be further ahead in South Texas than in any other location. So we're looking at a commercial site there in Brownsville area. We are looking at capability here, just north of the Cape. Puerto Rico has some very nice land as well. Georgia, potentially. I'd personally love to fly from the south point of Hawaii, but I'm not sure. I'm not sure we'll go there. But there's a number in play at this point. We're just further along with Texas.
Hi, Stacey Stovall, NASA Social Media. This question is for Ms. Shotwell. Two-part question. Is there anything in particular you learned from COTS 2 that will change how you approach this flight? And were there any test maneuvers performed during COTS 2 that will be skipped during this flight's rendezvous and berthing process?
I'm going to answer your second one first, and I meant to mention that in my opening remarks. So if you recall, the last flight was both the C2 and the C3 planned COTS missions. So the C2 was a fly under the station, test the comms, test the relative GPS and the absolute GPS systems. We will not be doing those tests because we demonstrated we could do it. So this time we'll be driving right to station. So we'll be skipping that particular piece. And as far as the learning goes, there's no question. Every time we fly our hardware and our systems, we learn something. We learned we like to be able to crop our imaging. We learned that on the last flight, and that was one of the reasons why we were successful in actually maintaining our position in the berthing box. So I think we made that flexibility a little bit easier. On that. There are a few minor changes, but in general, these vehicles are largely the same from the last one. Mm-hmm.
Marcia?
Marcia Dunn, Associated Press, this time from Mike Suffredini. What's the latest on the debris up there? I think there's a conjunction alert. What's the latest that you're hearing on that? And if the station has to move, is that going to upset the SpaceX launch? And secondly, when do you think you might be making an announcement or a decision regarding the new one-year crew?
Let's see. Yes, there is a conjunction that has a time of closest approach for Monday at 12:02 GMT. I think it's going to go green, though. Last word I got before I came in here is it's looking promising that it's going to clear. So if we do have to do a maneuver, then we do need to talk to our SpaceX friends because the station won't be where they're expecting it to be. and so they would have to adjust themselves accordingly. So that would be a conversation we'd have together. So we've started the discussions. There's a number of burns you can do, different sizes, and so we would work that with them and then decide what worked best for both. But I think it'll turn green and we won't require a maneuver. Let's see. We've decided we're going to do the